view as well. Oh, this inverter was beeping at me this morning. I had an error 8. It wouldn't turn the AC side on. I've pulled it apart, checked capacitors, checked components, no burning or anything in there. Everything looked completely fine. It has all 105 degrees Celsius for the Chinese caps in there. It's pretty well made for the price. There's a little set of jumpers in there, and like a shorter jumper. We have to make this thing supply 60 Hz pure sine wave. It's got plenty of filtration coils and everything, so it's definitely a pure sine wave. It's all silicon grade wiring in there, plenty of it too. I've cleaned it all out and I've lubricated the fans because the fans are kind of noisy and grimy. I've fixed that. I'm just running my Kelvinator now. I've 17 and 18 amps. I just supplying 10 amps from this charger. There's there was 5 amps coming from the solar panel, but the rain's come. It's only put 18 amps of DC, 200 watts. I couldn't run this fridge off my little 600 watt inverter because of the startup current, but that can start the fridge compressor up fine. I've rewired it all. Let's get that little light here. Just going to do a test run. The only thing left to do is do the earth. The body's earthed. It's right to touch it because the body's earthed. So it's running off the inverter. You can see how quiet that is. The compressor's running quite happily off an inverter. Modern technology versus this old technology. That's getting cold. Well, that's already frosted up, look at that. That's supposed to be pressed up against there, I think. Oh yeah. Oh, the soldering's come off. That's actually been moved. Okay. I've never seen that before. It's actually desoldered. Wow. Never seen that. Ah well. It still works. It's going to produce plenty of cold anyway when the door's closed, and chill my drinks, my beer. This is what's a really good advantage of these fridges. Take note, that's live. That's for the light. It'll run. Super efficient. These fridges are super efficient. No big, bulky. Some of a friggin' 800 or 900 watt defrosting element that plus the computer that it's in the modern fridges. You do the math. You get a modern fridge and you see how much power it uses compared to this old one. They're full of crap. These things don't use that much bloody power compared to the new fridges. The only reason it would use more power if it's always starting and stopping a lot. The compressor starts up or stops a lot, which isn't much different to a newer fridge anyway. The seals aren't necessarily good in it. It holds the cold in. That's running quite happily off the inverter. I could run this one too. I don't know if I'll do it at the same time. It probably will. It would, but the starter, if they both start at the same time, it'd be 10 amp kick. It probably could do it, but it would soft start because it's a lot of current. It would 3 kilowatt surge, this one. Now I've got the fridge on it as a load. We had no load on it. The solar, I unplugged the solar, it was charging fine. I plugged this solar panel into this one again. I was getting 16 volts, 17 volts. So I don't know what's going on there. Looks like the solar regulator died in this thing. The E8 error, it turned the AC side off. I wonder if it's the solar regulator that just played up and died in this thing. I'm not sure. They've got an E8 error. It said E8 and it was beeping and flashing at me a couple of times. I was doing it randomly and turning the AC side off. Now it seems to be working fine with the solar panel plugged in. There's no sun because of the bloody rain, so I got this supplying 10 of the 18.4 amps. Yeah, it's working hard. When the compressor stops, it'll top the batteries up. That's what that's going to do. I should get a little 100 volt step down transformer from my oscilloscope so I can plug it and probe this thing safely, and we'll look at the sine wave when this thing's loaded, just to get a good how noise free it is. Let that close, that's going to cycle and let it turn off naturally. Then I'll turn it off. Let it do a full cycle. You see the compressor's not there. I've got to make up a jumper from there to that. And that goes to the mains earth, which is jumpered through to the main cord. So from earth to there, they've got to connect that to the compressor. Then that'll be earthed. And then they've got to extend these and jump those to there. Then it's all earthed. That's all it needs. And they can put that all back together. We're going to clean this thing all up and just get a wet rag and soapy water and just clean all the crap off it, make this thing look really clean. Anyway, it's working quite well. The case is earthed, I think. Oh, hang on. No, that's all. Well, those rubber mounts are stuffed. It's earthed. Those rubber mounts are gone, so it's earthed. It's sitting on the metal anyway. The back's sitting on metal. There's no rubber there. Yeah, I will probably redo these rubbers too. Redo them. Then they're going to jump with that earth. And then they cable to the body here like this. That'll go on there like that to earth the pole component to this body. So it's not there. You want to get the best earthing possible here. I'm going to replace this one with a modern earth wire and jump to there. That's my main earthing point for everything. See the vibrations? Those little loops are important for the vibrations. It's running quite nicely. I don't even know what I got it on yet. What's that pointing to? There's a flat spot there. So it's pointing vertically, which is on 1, which is middle of the warmer and colder setting. I'm going to call it the neutral setting. Oh, that's getting cold. Oh yeah, that is getting cold. That's getting cold. So this is the sort of foods you want to run off the grid. You have a good inverter and a reliable amount of sunlight and a good set of batteries. You can run these things pretty much for free. That's the idea. Keep this thing off an inverter and keep my drinks cold in the summertime. Awesome. Pretty long too. Nice long cord. Anyway, I'm happy with that. This inverter seems to run fine so far. I don't know what its problem was, but I might even recap it with Japanese capacitors. Get some Japanese capacitors of the same rating and temperature rating. Let's put Japanese caps in it. It does supply 1500 watts, and it's got. I checked on the main, that DC side, positive and negative. There's 3 fuses, 3 40-amp fuses each on each input into the main board. So it's got 120 amps on each of the positive and negative side. So it's got 240 amps. This thing will supply and pull more than 100 amps, and you'll be happy with it. I've pulled 16 or 1700 watts from it. I pulled 2 kilowatts from it. Running a little heat. I did it for about 5 minutes, then it turned off because it's not ready for that. But amp wise, I was pulling about 180 amps at that time from the batteries. I was worried the fuse input was on below, but after seeing it's got 240 amps of fuse rating in it, it's fine. The earthing is good. I've checked all the earth. There's no close contacts touching each other. There's no that sort of risk. It's all earth through to here, all the way through, so it's definitely complies with the Australian wiring standards. Didn't say that when I bought it, but the manual doesn't say it either. But I've checked and it does actually comply. Things have warmed up now. Dropping. I've got this one, 35 amp hour, and that 35 amp hour. 2 9 amp hours, a 7 amp hour, 7 amp hour, 17 amp hour, 4 amp hour, 7 amp hour, another 7 amp hour, and a semi-dead, semi-revived full river battery, 20 amp hour, which is not supplying 20 amp hour batteries, pretty much toast. It does hold a charge now, but I'm just parallel charging it. Got to get some more golf cart batteries so they can have this something like this in the shed here. and it'll be running all the time. I could hook this car battery up to it, but it's not a deep cycle battery. Anyway, yeah, I can feel just a little bit of heat rejection building up on that. Yeah, as I said, I can only touch this because this is earthed. Touching the, yeah, you don't want it. This is say if this thing fails, you get a zap, but the inverter will turn off anyway because it was short to earth. But yeah, I can getting some heat rejection. It's definitely working. Definitely working. Anyway, I'm happy with that. And the inverter, and then it can run this fridge quite nicely. Thanks for watching.